Because what did they discover? These two
That the
astronomers.
expansion is speeding up.
Crazy. All people thought about expansion what?
Slowing down.
So logical. So logical. Because it's the force of gravity, right?
Yes.
Okay. Your theory, can you explain anything about that chaos?
No.
Okay.
What force is driving all galaxies to rush away from every other at an ever-quickening speed? Well, the most promising answer comes from an old idea of Einstein's. You see, we are all used to gravity being a force that does one thing: pulls objects together. But in Einstein's theory of gravity, his general theory of relativity, gravity can also push things apart. How? Well, according to Einstein's math, if space is uniformly filled with an invisible energy, sort of like a uniform invisible mist, then the gravity generated by that mist would be repulsive gravity, which is just what we need to explain the observations, because the repulsive gravity of an invisible energy in space, we now call it dark energy, but I've made it smoky white here so you can see it. Its repulsive gravity would cause each galaxy to push against every other, driving the expansion to speed up, not slow down. And this explanation represents great progress, but...
Georgie, and we talked with you a lot about that mist, which is called dark energy. What can you tell us about dark energy?
Well, Einstein thought that this matter exists to pull everything together.
Good. But no. Einstein thought that there is some kind of stuff in universe, some kind of mist, some kind of liquid, but we call it dark energy. Not together, repulse. It's a
all right.
repulsive force. And what does this repulsive force do with galaxies?
Well, bring them closer to the edge of the universe.
Thank you. But talking about the edge of the universe, just force them to speed up faster and faster from each other. Okay.
Well, it seems like they also stretch the universe itself.
Perhaps. That's interesting. But you say the edge of the universe. What is it? Where is the
Edge of the well, like the point where it ends.
And?
Well, it's abstract, all right.
Oh, good idea. That's abstract. Absolutely, it's not possible to understand how it works. Good.
I promised you a mystery here in part one. Here it is. When the astronomers worked out how much of this dark energy must be infusing space to account for the cosmic speed up, look at what they found. This number is small,
Georgie, point. Can you see a point?
Yes.
And after that, how many zeros about?
Well, maybe like 50.
Thank you. 50, which means that from calculation point of view, dark energy is a weak or strong force.
Well, if such small quantity is enough, then it must be really strong.
No. From calculation, I thought that this zero should be not in front, But behind all that numbers, it should be millions and billions and billions and billions of tons of, or I don't know what.
But this expresses what? Its strength or its quantity?
I think it expresses its weakness.
All right.
It is so weak, I think. But it's a calculation of mathematics. But in mathematics, Georgie, you can find a lot of tricks. But please, can you read? Okay.
Expressed in the relevant units, it is spectacularly small. And the mystery is to explain this peculiar number. We want this number to emerge from the laws of physics, but so far no one has found a way to do that. Now,
okay, we'll finish here, but a usual question when we sum up, when we come to some result. Georgie, why do these scientists satisfied? They are satisfied only when the theory is completely 100% supported with a mathematical equation.
Well, because this is like a proof.
Thank you. It's like a proof. And as far as I understand, nobody can find a formula or equation which can explain this number. This number is so little, so it means that the theory doesn't work with this dark energy.
Perhaps.
Okay. But can you write somewhere? Do me a favor. So please write down 5 minutes and 41 seconds.
All right.
5 minutes and 45 seconds.